Presentation across them all. Let me hear one more as we're warming the audience up, waiting for a few more folks to join. If you were to summarize the quality of your current data pipelines in one word, what would that be?
No obscenities, please. This is a family webcast.
Yes. And the last question, I think there's a slight delay between our audio and how comments roll in. So the last question before we get things kicked off, drop a comment in the chat. What are you most excited to learn in this webinar? Put that in the chats and then we'll make sure this is live. So we'd love to bend the conversation and tailor this to the audience. So drop a comment in chat. What are you most excited to learn? What do you want to take away from this webinar? And then we'll get things started here.
Someone's pipelines resemble lasagna.
Lasagna, that's good. I guess it could be taken in a good way or a bad way. Sometimes like lasagna, it's sophisticated and it's well put together. It's got layers, right? And it can look very beautiful. But sometimes I throw a slice on my plate and the thing just like spreads all over and turns into a mess. So who posted that one? Yvonne, tell us, which did you mean by lasagna? Do you mean very well put together layers of your lasagna, or do you mean once it's scooped onto your plate? Which represents the data quality of your platform?
Right, just the right consistency, hot,
yep.
Not too hot.
Yes. Great. Okay, I see some people saying they want to learn about Iceberg internals. People want to learn about interop and uniform. Some people want to learn about the role of OneHouse. I think we can touch on all these different characteristics in the webinar. So what do you think, Floyd? We got critical mass. Should we get started?
I think we do. And we're at a good point in time as well. So I want to start out by asking you, Kyle, you have a strong background in data. In fact, when we were preparing for this webinar, I had not realized how strong your background in this stuff was, starting before some of it even had a name. So please tell us a bit about how you got to this point.
Thanks, Floyd. I appreciate it. Yeah, I've been in data about 10 years myself. The first half of my career, I was leading data engineering teams to build petabyte scale, terabyte scale data lake platforms for global services like Microsoft Office, Bing, and Cortana. Had some really awesome stories to share and dive into there if we had time. The second half of my career, I pivoted to spend time building data products for data engineers. And so I spent some time in the Azure machine learning world at Microsoft. And then the last stint that I had there with Microsoft was with Azure Databricks. And some people might know that relationship of Databricks and Microsoft that came together. So I was there when we first launched Databricks on the Azure platform. And then I was also there when we first created and launched Delta Lake, first as a Databricks proprietary feature, and subsequently when we decided to open source the project. And since then, I've helped hundreds of customers build data lakehouses. And I've had a lot of fun doing it. So in 2021, I actually bumped into Vinod, who's the creator of Apache Hudi. And he told me about his vision for the company he wanted to build and goals to help make it easier to automate data infrastructure around data lakes. And I was sold right away. So I jumped on board and I'm excited to be here and help build OneHouse. Now I've spent the last 5 years involved with large-scale enterprise deployments across 2 of these leading projects across Hudi, Delta Lake, and Iceberg. So I have a wealth of firsthand experiences, and I'm happy to share some of that today.
My summary is that you had a full-time job building data lakehouses for people. Vinod came along and told you he was going to make it easy. You realized you were going to be out of work. So you jumped.
That's probably right, Floyd.
So once you got into this new thing, you wrote a blog post in January about the major open source projects for the Lakehouse, which of course are, to give them their full names, Apache Hudi, Apache Iceberg, and Delta Lake. and you looked at health, performance, and features of each of them. And we're going to be getting into that. But I want to ask, how did that come together? What gave you the idea, and how has it gone since January? I think we've gotten a lot of feedback.
Yeah, great. Yeah, I think I have always been reading up on the space and following and learning. And I saw several articles online that attempted to write comparisons on these projects that I think were missing a little perspective on what matters once you actually take these projects into production workloads. So I decided to write up the blog in a few different sections. One is to look at basic feature comparisons. But then also go into community statistics, performance benchmarks, and finally call out real world use cases on how you can use these projects in real life and where their strengths are. So one thing in particular that I've heard a few people comment on and send me messages about the blog is that every cell or every row that I put in there, I try to link to evidence and real documentation for their projects. And it's kind of funny. One person even told me that now they use my blog to navigate the documentation for some of these open source projects now, which I think is kind of a cool side effect that I never imagined would happen. But anyways, these projects are all moving very fast. I know there's a few new features in each project since my last update of the blog. So I plan to do another refresh later this year and hopefully keep this content evergreen and useful for everyone in the community.
Well, at the end of the day, it's all about me. And I was going to have to write a blog post, to summarize this webinar we're doing. But then I realized I'll just ask Kyle to update his, and then I don't know.
Nice.
So origin stories. We hear about what's happening now with each of these projects, and there's been a ton of activity and a ton of success really around the Lakehouse in just a couple of years. But how did these things all start out? What was it like back at the origins that you were present for some of yourself?
Yeah, let me get some slides up. I prepared some slides to look at some of these. So let's see if I've got the right screen share going on here. And we can dive into this. I think folks can see the screen well. Drop a comment if you can't for some reason, but I will start diving in. So what I did on this slide, I think some people might be interested, is I tried to go and grab close to the first commit of the README files for these projects when they were first open sourced. And I think this is interesting to look at the origin stories of these projects because they all had different roots and different focus areas when they were starting up. And I think some of these focus areas and roots are still driving kind of how the communities grow today. So first we can look at Apache Hudi, which was open source from Uber in 2017. This was at a time when Uber was in their hyper growth phase. They needed to build a petabyte scale near real time platform to process all their trip data, run fraud detection, so many more things inside there. And before the Lakehouse term was popular, the Hudi community initially called this a transactional data lake. They were migrating from some very large Vertica data warehouse setups, and they wanted this to be more portable inside their data lakes and get it moving faster and near real time. So Hudi focused from the beginning, if you look at some of the verbiage inside here, on transforming batch to incremental processing and trying to get data moving at near real-time speeds. Then if we look into Apache Iceberg, this was open sourced in 2018 from Netflix. And if you read some of their origin stories, they were struggling a lot with S3 scale limitations, and they wanted to fundamentally replace the Hive table format with a new and portable metadata layer. Delta Lake then was open sourced in 2019, and some of the initial goals were to replace warehouse-like functionality with Spark and make Spark the gold standard processing engine across the industry. So these are kind of where some of them started, and I don't know if it's too early, Floyd, to share a hot take. This one I'll go just into my personal view. One of my personal hot takes is I think most people believe that these projects are very similar, and they are very similar, but I think most people believe that it's just a matter of time before each one builds the same feature sets out and they kind of converge. Actually, my personal opinion is that I think these projects are actually divergent. And I think they're building towards different goals and for different purposes. And I think this will become clear the further that we go down through the presentation. But
Okay, good. I look forward to seeing more about this. Um, there are experts on each of these projects, but there aren't many people who know a lot about all three of them. So I called this section "Under the Hood" as a bad pun. But can you give us a bird's eye view of what each of these is actually doing under the hood, and where there's similarities and differences?
yeah, sure. First, let's talk about some of the common technical fundamentals. There might be some people that are coming in new to this space as well. And let's take a bird's eye view on that and see how these common technical fundamentals can actually make an impact on your data platform. So if I were to try to give you a simple one-liner, sometimes it takes a while to explain these things, but to give you like a simple one-liner of what Hudi, Delta, Iceberg are, these are metadata abstractions on files in cloud object storage. And each project does this slightly differently. There's some diagrams that I lifted from an interesting article we'll look at later of how Delta, Iceberg, and Hudi organize that metadata around the files in storage. And Delta Lake does this with a JSON-based transaction log. Iceberg uses an Avro-based manifest file. And Hudi has a powerful timeline and an index metadata table behind it. And so anyways, once you create a metadata abstraction on files in cloud storage, now you can unlock foundational characteristics like tables and SQL semantics, something very basic and fundamental to make it easier to use your data. Once you have this, you're unlocking schema evolution capabilities. Because files in storage are immutable by nature, having that metadata layer on top also enables you to unlock ACID transactions. And this provides the atomicity and isolation necessary to enable updates and deletes on this otherwise immutable storage. This metadata abstraction also provides an opportunity for tracking statistics and applying data layout optimizations for performance tuning. So for example, Hudi's merge on read characteristics. We'll get into talking about what is more copy and write and merge on read a little bit later, but because you have an abstraction layer, something that Apache Hudi was able to do since the very beginning is they have data files that are Parquet files that Hudi calls base files. And then as updates come or as small writes come, Hudi is able to efficiently write these in row-based Avro files, and they call them log files. And so to get the fastest writes possible, they can land in Avro files and then later can be compacted into fast access files, Parquet columnar files for fast consumption. And because the metadata layer provides that abstraction, you're able to play and manipulate with these capabilities under the hood. So yeah, I think it's really interesting to see just there's a lot of commonality in how these are established and these common foundations.
Okay, very good. So that's a quick look inside. When you look up on the shelf and you see your spices, you wonder which one to put in your lasagna, for instance. So what is each Lakehouse project especially good at? Where do they stand out, and how does that relate to the origins and the original goals of each project?
Yeah. For this view, I think it would be useful and worthwhile for us to switch over to look at the actual blog. Let me switch my screen here and get this on the screen. All right, I think this should be visible by people. Comment in the chat if for some reason it's not visible. But yeah, this is the blog that I wrote, and we can step through and look at some of the feature comparisons. First, let me show you how it's organized at the high level so that people are oriented, and when they come back to research it later, they know how to go through this. So in the feature comparisons, I try to break this into categories. The first category is around like read-write features, after which we go into discussing table services, platform support, and ecosystem support. Then there's other things around community statistics, benchmarks, things that we'll look at a little bit later, I believe. Anyways, let's talk about some of the read-write features and unpack some of these rows inside the blog. Like I mentioned before, because of the common foundation that each of these projects provide, some of these are very similar for the projects, the basic ACID transaction that are possible and capable there. All of these projects are by default using what's called a copy on write mode, where basically you can rewrite Parquet files and version these files as you're writing new data. I mentioned briefly merge on read write mode capabilities that Apache Hudi has had since near the beginning. This merge on read capability allows you to get faster writes and balance between write amplification, read amplification, and how you're able to tune and balance the speed of your pipeline. So Iceberg also added merge on read capabilities later this year, but I think it still has pretty limited functionality in the type of queries that are available to consume that data, and the configurations that you're able to tune and balance to manage these characteristics of your pipeline as well. Delta Lake doesn't have merge on read capabilities specifically. They just created something called delete vectors, which can help some scenarios as well. I won't read every cell on this list, so I'll speed through and just grab a couple as we go. Maybe let's talk about indexing here. This one's pretty cool. Apache Hudi has a first of its kind pluggable indexing subsystem for the Lakehouse. And what this means, so let's think about as you have a table that you're writing to of data, and this data is growing over time. And let's just cook up a scenario here. Let's say that over time, every commit that you write, every time you write some piece of data into the table, it's the same size, okay? So you're writing some 100 megabytes or 10 GBs every day of data into this table. And as your table starts to grow over time, usually the amount of time it takes to write into that table will also grow linearly with the size of the table as it grows. But if you can employ the right indexes, and which Hudi has several different indexing strategies, what you can actually do is avoid that linear scale and growth. And if the size of the incoming data remains constant and the size of your table is growing, you can actually get close to constant amount of performance and speed necessary to write data into, especially if there's a lot of like updates and deletes and upserts, things like that. Some very powerful techniques.
Are you trying to break the second law of thermodynamics? You know, there's no such thing as a free lunch out there in the universe.
No. I'm not trying to claim any kind of free lunch here, but you can really bend the characteristics of how that data is flowing in at scale, especially. So really exciting. People should dive in and check out the links that I've linked in here, and there's documentation and blogs and good stories about this out there in the industry too.
Yes, we should have promoted this a little differently, because I'm realizing just with the depth, you know, it has some characteristics of a graduate seminar rather than just a quick gloss on some high points. One of the comments says, "This blog says it all," and we're going to take that as a compliment. But the action item out of that, though, for all of you out there is don't be afraid to take some time. Yes, thanks, Samuel. Don't be afraid to take some time after the webinar and really dive into this, because there's a lot of detail in here. Yeah. And it's good stuff, and it's gotten a lot of attention, as Kyle said. And then people, to justify all their investment in this blog, they end up using it as a kind of a dashboard for access to everyone's documentation.
Hopefully it's not like dashboard style, green, yellow, red, this like Christmas tree dash. Hopefully it's not that far, but yeah, let me tell you about a few more. I'll cruise down through the list here. Let's peek at incremental queries, perhaps. So this is something really powerful that Apache Hudi offers, is the incremental processing framework. And what this means is I try to write a little question underneath each of these headers so that people can understand this and see how it fits in. So can I obtain a change stream for a given time window on the table. So Apache Hudi allows you to look at the diff between where the data was at versus what were the new and incoming changes that need to be applied to a table. And so this unlocks a way to very powerfully only process new data throughout your pipeline. I'll talk about this in more depth later on. Delta Lake created something that's called a change data feed, which after writing this at first, it was in an experimental mode. Maybe it's more mature at this point. Maybe this turns to a green checkbox for Delta Lake actually when I update the blog next. And on the Iceberg side, you can do some of this, but you can't. You can only incrementally read appends, and so I think that kind of loses some of the spirit inside what incremental queries can actually do for you. Keep on moving. Everyone can do time travel. Let's skip down through a few things. Concurrency control. I think we'll talk about this in more depth later. Apache Hudi offers, well, all of them have what's called optimistic concurrency control. And the basics of this, what this means is if you have multiple writes that are coming in simultaneously, as long as they don't manipulate and change the same files, they're free to go. If they do conflict and change the same files, then one of them will restart. One of the write operations will be kicked back and restart and reapply their changes after one of them succeeds. So that's a really nice capability that all of these systems offer. Apache Hudi goes a little bit further. There's a blog linked in here that talks about OCC, MVCC, and non-blocking table services that Hudi offers. Hudi has some primary keys and pre-combined keys that help you dedupe data as it's arriving and keep duplicates out. Let me skip down through a few. Oh, here's a great one for Apache Iceberg that's called partition evolution. So this is interesting where you can change the partitioning scheme of your data as the data is evolving. So sometimes your data is changing or certain characteristics are growing in different ways as your company, your business, your applications are evolving. And so sometimes the partitioning scheme you choose up front, if you choose it at too fine-grained of a level, this can not be ideal in the long run. So Iceberg has this nice way where you can change that partitioning scheme. So old data still lives in the old scheme, new data gets in the new partitioning scheme. And as long as you're not trying to write queries that cross over the boundaries, you can get some good results there. Both I've heard from the Delta Lake community and the Hudi community. They look at it a little bit more as an anti-pattern. They do it slightly differently. Like Hudi, for example, recommends to choose coarse grain partitions, and then you can do more of the fine grained and the evolution of the layouts with clustering. And clustering is like some sorting mechanisms. So with Hudi, you can adapt these over time and recluster asynchronously. Yeah, so you can achieve the similar end result for adapting the performance and the layout optimizations of your data as your data is evolving over time. You can achieve the similar result just through different mechanisms. Okay, let's cruise on down and talk about table services. This is where I think things get really interesting. So first, let's talk about capabilities and then how you operate these table services. So all the projects have, and they use slightly different terminology or words on some of these, but they all have basic file sizing, cleaning, sorting, clustering kind of services. But one of the single biggest differences between these projects is how you operate them. And so maybe I can describe this first just from like personal experiences. And what I've seen behind the scenes is I've worked with so many different organizations that have built out these data lakehouse platforms. So think about, let's say you're running a data pipeline, and let's say you're running in some kind of hourly batch windows. And every hour you ingest new data, you write new data into the system, and say that job takes some 10 minutes every hour that you're running. Everything will be great. OCC is there to protect you, readers and writers. There's no kind of concurrency challenges. But now let's say you need to speed up your pipelines and you need to start writing every 5 minutes, every 1 minute, even every 10 minutes, right? Now this window of time that it takes to write your data, imagine, it's constantly writing and changing the files, manipulating the files. Now imagine you need to come and run a compaction job or a file sizing job or a cleaning operation. And say the cleaning operation, the compaction takes 10, 20 minutes on its own to run. What you'll find is that as you're writing and changing, manipulating files, that's going to start kicking out these operations, or vice versa, right? And it gets into lock contention and just a lot of challenges on operating this. I've seen this in many places, and there's lots of even recent material written about this, from folks in these various communities that have struggled with operating the services at scale. So
Just a
yeah,
just a quick call in
yeah.
Catching you in mid-flight here, and a little off topic of exactly what you were just talking about, but we're getting some comments about copy on write versus merge on read, and apparently the different projects have different approaches to this. So if you can shine a little light on that as you're going, please.
Yeah, sure. Yeah, I might be able to pull up a diagram that makes it more clear too, what copy on write and merge on read are doing as well if we have time. Thanks, Floyd. Yeah, so this table serves, I think this is a really big deal on how they differ and how they operate. And what Hudi does is it has a timeline service that allows you to, like, all these can be automatically scheduled for you, managed for you, like the file sizing, cleaning, compaction. You don't even have to worry about it. In other systems, not only do you have to make sure that it's running and working with concurrency control, but you have to like monitor and observe and schedule it and do airflow operations, whatever it takes to actually operate these services. So I think let's break to the next section. People can go and read more about platform support, ecosystem support on their own time. But hopefully this gives a good view, Floyd, on like just pure feature comparisons.
Yes, good. Thank you. There was I'm going to make a old joke that Supreme Court justice, the Supreme Court was once asked to rule in a case about pornography. And one of the justices famously said, "I can't define what pornography is, but I know it when I see it." It's similar with how open a project is, right? Everyone knows what a truly open source project is. They can't define it, but they know it when they see it. But you actually dissected this and took it apart and looked into the guts of each project's daily operations to see, are these open source projects, and what's the health of each of them?
Yeah, let me grab another slide here. I'll throw this on. Oh, I think you can see it on the screen. Great. So what I did, I went through and compiled a bunch of statistics from publicly available sources, GitHub, Slack, Twitter, these other areas where people are, one, discussing, but also contributing to and collaborating on these projects. And I think the stats stack up where it's obvious Delta Lake has the most public attention. They have the most eyeballs and users in their communities. Then when you get into statistics in GitHub that are looking more about engagement and contribution, Apache Hudi has more authors, more commits, more PRs, watchers, forks, all these kind of indicators that talk about the health and momentum of the communities. So I think that Hudi and Iceberg, they're catching up on their growth in these communities. And on social media channels specifically, I think Iceberg's benefiting from recency of marketing after Snowflake announced support from their project. These projects, they're all growing and have strong communities behind them. So I'd advocate, if you want to learn more about them, jump into any of these communities, follow them on Twitter, jump in the Slack channels, go on GitHub. You can contribute to any of these projects and help move this along. So one last thing I'll call out on diversity that you were bringing up is Delta Lake's primarily driven, like if you look at who in the community is contributing, and you can break down these stats by organizations as well. It's primarily driven by Databricks, which could be seen as a pro or con. In contrast, Hudi and Iceberg, they have a diversity of many large organizations that regularly contribute to the project development. So yeah, that's how I think some of the communities stack up.
Lots of active stakeholders there.
Mm-hmm.
And then another thing that's hard to define precisely, but you know it when you see it, and you definitely know it when you experience it, and you know it when you experience the opposite, is performance. And you know, there's lies, damn lies, statistics, and benchmarks, right, out there at the extreme of arguable numbers. But tell us something about benchmarks, and especially point out if there's anything really notable that's might cause people either problems or open things up, you know, that they're not used to being able to do for any of the problems.
Yes. Okay, great. This is a fun topic about performance. First, I'll call out, do we want to call these benchmarks or benchmarketing? Because the first disclaimer I want to call is benchmarks rarely represent your real workload. So I want to advocate first and foremost that everyone here does their own testing on their own workload and see how things perform. And also, as you read through benchmarks, see if code samples are shared and if the benchmark is written and transparent in a way that is reproducible. So you can pick it up and try it for yourself, manipulate it how you need to tailor it to your environment. When the code samples are out there, that's a very good sign that these benchmarks aren't trying to hide something under the scenes. Anyways, I grabbed a few benchmarks that we can look through and talk about today. And some of these are around TPCDS. I think that's the most common benchmark comparison that I see folks use. Very powerful benchmark. It also is using append-only workloads. So I think there's some pitfalls in how it actually can represent your workloads. And one more comment that I'll make before we dive into some of the numbers here on the screen is that when you're looking at these comparisons, check out for this common mistake. So Hudi, by default, it's using an upsert operation. And so it has significant overhead on the writes where it goes to look up if there's existing data that needs to be changed or updated before it commits. And so if you're trying to compare upserts versus inserts, it's really apples versus oranges. So to check out that as well as you read some of these comparisons. But anyways, the two on the top are traditional TPCDS benchmarks, and one was produced by DataBeans. And from the OneHouse side, we also contributed back and reused some of their framework and published as well. Brooklyn Data Benchmark, they published one, and they had all the samples out on GitHub. I have links to all of these references and the statistics. So for folks that want the slides, drop a comment. We'll send you all the slides, and you can get these links and go dive in and click through and read these in depth if you'd like as well. And then a special call out. So there's some TPCDS ones on the top. But I want to make a special call out as well because I read this really great paper that came out of a research team at Microsoft. They call it the LST bench. And this LST bench, the purpose of the paper that they wrote wasn't necessarily to compare and choose a winner, who's faster, who's slower, but they were proposing a new framework for how to run and measure benchmark comparisons of Hudi, Delta, Iceberg in these Lakehouse ecosystems. And what they did is actually what I think is one of the best benchmark frameworks I've read till date on these Lakehouse projects. They took a TPCDS base workload, and then they applied mutations that closely or more closely represent workloads in real life. They also used the operations that are present inside the projects, like cleaning or the optimizations around file sizing. They perform these maintenance operations, and they measure how the systems perform over time. They also introduce new ways to compare the formats. Not just around like performance or the time duration of like a query, but also how does the performance stand up over time, and they introduce concepts around how to measure resiliency and some other characteristics. So I'd advocate go search. You can find it on Google if you don't want to get the link on the slide here. Just search for LST bench, and the research team over at Microsoft, I think, is doing an incredible job. And more folks should jump in and talk about it, contribute to it, and let's foster more ideas and development in these areas, because these are new and emerging technologies. We need maturity in how to measure and compare them.
Well, that thanks for just a quick point about this is that also these are very active open source projects. So the good news is that if you're having a problem with performance or any use case with any of these, you can get into the open source project and ask for help. And of course, the bad news is that people will say, thank you for bringing that up. Why don't you fix it? But that's part of the thrill of working in open source. So these aren't fixed, immutable software bases that you can't do anything about. I took a look at some of the people who are joining, and there's a lot of people on this call who can go make a difference on some of these things if they want to.
Yes, let's do it together. The last one that I wanted to call out, like if you don't trust any of the others that are up on the screen, here's a real practitioner, a real user out in the environment, Walmart. And they wrote up a really detailed blog. I think it was really great, right? They describe in depth what their workload patterns are. And this isn't just some simulated test, like all the others are simulated environments. And they took their real data, their real operations and write patterns, and they put them to the test. And they measured it across performance, features, capabilities, future roadmap, all these different characteristics. And they're running at massive scale, one of the largest platforms out there. And that characteristic I described earlier on operating the services with optimistic concurrency control, Delta Lake was failing their background compactions. That same thing I brought up cropped up in the Walmart workloads. And Iceberg failed their write operations altogether. So in this kind of environment, which you can consider as a larger outlier in terms of scale, Apache Hudi not only succeeded but shined in performance and other characteristics here as Walmart measured. So I'd advocate go check out the blog. I think it's a really interesting write-up, and there's several others that are like this out there that you can find. So yeah, that's what I want to call out on performance.
Okay, so the phrase that's always used in our work is price/performance. So there's the performance side you've just gone into. Is there a difference in cost? Cost to us, price to the providers, cost to the users on any of these projects?
Yeah, good call. Because especially performance improvements directly lead to cost savings, right? So everything that Hudi, Delta, Iceberg, that these projects do to right-size your files, sort the data in great ways, partition it, clean it, reduce S3 API calls, all of these across Delta, Hudi, Iceberg, they are leading to cost savings to your environment. And these can be large cost savings. One area that I grabbed a couple stories on is around Hudi's incremental processing framework. And these recent blogs, I think, are powerful reads as well. You can read how Uber was able to save 80% on their overall compute costs and reducing this across millions of vCores. So they talk about in depth how they evolved their more batch style workloads, their batch pipelines, to leverage this incremental processing framework. That was in April. And then just right after, in May, Zoom also wrote a blog in collaboration with AWS, talking about how, maybe we even read a little snippet here. It says, we showed that the cost of EMR clusters can be reduced by about 82%, while bringing down the storage cost by about 90% compared to the prior HDFS-based architecture. All of this while making the data available in the data lake within 5 minutes of ingestion from the source. And it's not listed in this little snippet, but in other parts of the blog, it talks about their scale. And they're running, I think it was hundreds of terabytes of data a day into these systems. And to achieve that level of cost savings on both compute and storage, I think is pretty incredible. So great cost saving stories across the board. And if you haven't picked up Hudi Delta or Iceberg yet before, you got to jump on it, because this can make a significant difference to your organization's wallet, but also get that data faster, right? Like here, I think it's incredible. A lot of times this is a trade-off. If you want your data and you want your data faster, you're going to be paying more. But with things like here, like Zoom described, you can get your data faster and cheaper at the same time. So why not? What's there to lose?
I keep mentioning the second law of thermodynamics to you, and you keep saying things like that. but no, it's good stuff. I'm just going to mention as a quick aside, those of us who explain things as part of what we're doing. So if you're explaining to bosses, colleagues, what the Lakehouse is all about, Uber is a great example of explaining to people how this works. When your car is coming to you, you need real-time updates on the location of that car, and they need real-time updates as to whether you bailed on the call. Are you still there? If you're texting them, I'm waving my hand on the left corner, that has to be in real time. But a lot of what Uber does, the game just let out, the number of drivers is low, needs near real time. And so that's really one of the great things about the Lakehouse, is it gives you a flexible and you can make your own trade-offs in terms of time, investment, what your SLAs need to be for a given. So it's a nice pyramid from real time. We have experience with real time. We have experience with batch at the bottom of the pyramid, the slowest updates. But the near real time field is really becoming a big deal. And the Lakehouse is probably the single biggest technology enabling that across all these projects. Did you see that at Microsoft, Kyle? You were here when these requirements were emerging. Like, what were people saying early on?
Oh, yes. Oh, man. We so the first data lake that I built was in 2013. And when we built this, this was for Office application. It spread across desktop, mobile apps, web apps. And so some of these that are well connected, like web apps, the data's coming in fresh and hot and constant. But other things like mobile apps, desktop apps, you close the lid on your computer or you lose signal on your device, and that data comes in very late. And we had to create these very expensive, very wasteful, in my opinion, data processing pipelines, where to account for late arriving data, we would have to process, we had hourly slices, daily slices, but we'd also look back 7-day windows. And then at the end of each month, we'd have to reprocess 30-day windows. And so back in like 2013, when we didn't have some of these capabilities, I think it was slow, wasteful, and not efficient ways to build data pipelines like this. Although still incredible that the achievements and things you're able to, and the results you're able to drive with it. So
yes, and we can all take a look at our own organizations. Zoom being another good example, right? Of course, a lot of Zoom has to be real time. It's supporting communications between people live, but then a lot of the data about how the business is doing and about deploying resources and so on, again, can be near real time. So the reason I'm mentioning these things is not to highlight these companies, but to urge everyone to take a look at their own organizations and start through that lens and start to see what really needs to be real time, what needs that money spent on it, what can be near real time, what can still sit in batch, although there is a pretty big migration off batch, and some people are kind of not doing new batch stuff almost on principle, right? Just too damn slow. Excuse my language. So we've looked at a lot of things. Reading your blog post can tax the brain, and of course, going through all of these things is fascinating. And you can say, wow, that's a lot of stuff. What if someone's just getting started? They're catching, you said 2013, you did your first data lake. So that's 10 years now of experience and knowledge. And people who got in this early have 5, 7, 10 years of experience in these issues. What about someone who's just getting into it? The data world keeps, swallowing more people and more companies and so on. It just keeps getting bigger and bigger. And of course, the rise of AI and machine learning has turbocharge that even further, if you can even believe that. What about someone who's just getting started? How do you get your bearings? How do you make progress and make a contribution?
Yeah, I think sometimes it can look exhausting at first to go through these comparisons. There's so many different dimensions to it. So my recommendation would be as you're getting started and learning about Hudi Delta Iceberg, this lake house kind of architectural pattern on the lake, first start with some comprehensive research material. Maybe it's like what I presented today or the blog post that I have behind the scenes on it, but I don't want you to take just my word for it. I want you to test your own workload with your own use case. I've worked with hundreds of customers and seen the behind the curtains comparison tests, both as I worked on really close with the Delta Lake community and now a little bit closer with the Hudi community. Here I've seen some of those light bulb moments go off as people start to actually realize how these projects are operating under the hood, and they put it with their real data on their real workloads. One pitfall I've seen when people are beginners in the space and they're just trying out, they're running the Hello World samples, they're running the little simple Docker demos. Some of these projects are very thin formats and they seem easier to use on the surface. While Hudi actually has a bunch more knobs and configurations, at first this can feel like a burden for a Hello World demo. But when you actually build a pipeline that you operate in production, Hudi suddenly becomes a piece of cake once you get going. While it can be challenging or tedious to manage your tables with some of the other projects as well. So in summary, my recommendation is do your homework, try them out for yourself, and leverage material that's out there online.
Right, right. Okay, very, very good stuff. And there is some sign that people might be able to simplify these complicated. Oh, I want to point out that people from any different origin or any different group, or people who even like were suspicious of or didn't like each other, can get along. And Kyle and I are an example, because I worked at Apple for 7 years and Kyle was at Microsoft. People forget, but there was a time when that was the hottest rivalry in tech, between those two, suing each other, deposing each other, poaching each other's employees. And here we are working together at a startup.
Yep.
So
I can look past it, Floyd.
yes. And to that point, there have been a couple elbows thrown in discussions of different Lakehouse projects, but the point is we're all talking about the Lakehouse, right?
Yeah.
This new model of how to handle data is getting far more popular, and some people now almost kind of assume it as they set in to do their work. Like that's a first choice. That's a big change in just a few years.
Yep.
So with all that, people don't need complicated choices in their lives, and they can even, like, too much choice can slow down adoption. Is there a way to go forward and somewhat rise above these issues?
Yeah. This is actually what I'm most excited to talk about today. We can nerd out and go deep on these comparisons, but let's pause and think about the change in the data world over the last 5 years. And even if we think back further, okay, let's think about there was Parquet, ORC, Avro, these data formats that were created, and now they're universally supported across all engines, and there's no problems or qualms or gaps. Parquet, ORC, Avro, like just golden standards, right? But now with the emergence of any new budding technology, and as we looked at the timeline, this is 2017, 18, 19. We're not that very far in. So as these new technologies are built, there's now a complex matrix of who supports what and how does each format fit in. And so I think that there's some steps we need to take across the ecosystems to bring maturity into the integration of these formats and how it fits into the ecosystem. So to this end, let me put it up on the screen here, some slides. We announced in February of this year from One House that we plan to build this new open source project called One Table. And I want to tell you a little bit about One Table. Maybe if there's interest, drop comments in the chat window if you're interested to talk about this more in depth. We can have even a special session dedicated to One Table, and we can crack open the internals and talk about how it's operating and whatnot. But in February, we announced our plans to build this. And just last month, I wrote another blog to describe how it works, especially in contrast to Delta Lake's recent feature that they released called Uniform. So if someone wants to link at that blog in the chat window, it's probably helpful for folks to read as well. And first, I want to share, what is one table at the high level. Let's talk about why, how does it work, what's next, and some of the exciting things that are coming. So, one table at the highest level. It provides omnidirectional interop between Hudi, Delta, and Iceberg. And what this really means is, under the hood, these are all Parquet files. This is all the same data, and omnidirectional interop. This means that metadata layer that's on top that we talked about and described, you can seamlessly translate and transition this metadata from one format to the other. And so no matter what the incoming data is or how it's being written, say you're writing it as Delta Lake format, you can seamlessly translate this to Hudi or Iceberg or vice versa, and you can switch these back and forth. And what this means is any reader that comes to the table and wants to read your data, they will see it as if it's a native table in any of these formats. It will look like a native Iceberg table, look like a native Hudi table, a native Delta table. The consumer doesn't see a difference on these, how it's exposed. So some people might be wondering, well, why did you build one table? What's the motivation behind this? And actually, if you think about from a OneHouse perspective, what our company mission and vision is to decouple query engines from data management and data infrastructure and how you operate those foundations of a lakehouse. And so we want our customers that use our product to have complete flexibility in what they use downstream on top of their data infrastructure. And so as the ecosystem's evolving, and when some vendors get a little more picky than others, like for example, Snowflake picked up just support for one, being Iceberg. We have customers that want to use sometimes both Snowflake and Databricks together at the same time. And great, well, I will help you bring your data in and represent it as Iceberg and Delta and or Hudi if you wanted it. And it doesn't matter too much to us. So we started it as internally a product feature for our customers, but we want to bring this to the rest of the world and of course allow contribution and development in the communities. So this is going to be released soon in a standalone open source GitHub repo, arm's length from Hudi, arm's length from OneHouse. We're hardening this right now actively with co-owners who are vested separately in Delta and Iceberg, because we want this to have no biases in between or development from just one side of the aisle or the other. Because if we have this neutral environment, this neutral repo, it allows us to collaborate in new ways and start to create inroads between these projects, make it seamless to leverage the best and the benefits of all three. So yeah, I'm really excited about this, and if folks want to learn more, happy to chat.
It says on the and R Singh from our comments here says would love to contribute, and it says on your slide, send me a message. How does someone do that?
Yeah, find me on LinkedIn, find me on Twitter, find me. I think the last slide will have a email address that you can send to info@onehouse.ai. Reach out, and we'd be happy to chat.
Okay, great, very good, and you'll see Kyle when something gets hot. You'll see Kyle out there, so he's definitely findable. And we may need to do another webinar just to go into the depths of one table and interoperability. You've shared a lot. Thank you very much. And of course, there's more available for people to go into further. We do not yet give college credit for any of this. I'm sorry, we're working on it. That's just a joke, though. We're just doing our work. So if you would give us a final summary on the choices people have to make when they're looking at the formats, how this relates to where each of them started from and where it's gone since in the 5 years or so that we've been.
So if you joined late, if you joined halfway through, here's the final summary. This is probably the most common question people ask me, because they know that I've been deep with at least 2 of these projects, and I've studied and researched across all 3. So they ask me, which format do I choose, Kyle? How do I pick? So it's hard to say. Everyone's individual experience, workload, use case, they're all different. Here's maybe some guiding principles that you can look at. If you've got mutable data, CDC workloads, low latency requirements, or you want to save costs on incremental queries, Apache Hudi is a great choice. If you are using Databricks and you want that fastest premium Spark, or you want an easy to get started kind of table format experience, Delta Lake's a great choice for you. And if you need Trino or Athena or Snowflake writes, if these are in your ecosystem, you're not as sensitive to performance, or you would really love to take advantage of partition evolution, Iceberg's a great pick for you as well. So that's kind of just at a high level. It's hard to really say. It's not the same for everyone's environment. So do your research and do your testing.
Yes, very good, very good. We had a question asking about specifically something you mentioned, but maybe if you can go into a little depth on this and even refer to the blog post you wrote on this topic about uniform and how does what Hudi offers and then OneHouse product and so on, how does that relate to uniform capabilities?
Yeah, sure. I wrote up in-depth comparison discussion also of one table and uniform. So if someone's able to link that on the chat window, that will be easiest. I might even have it handy here if I can grab that. Yeah, let me change my screen share. Yeah, so you can read this offline in more depth. Basically, some of the core differences. Uniform comes from the Delta Lake repository directly, and it provides a one-way translation mechanism. So you start with Delta Lake, and then you can optionally interop that metadata to Iceberg or Hudi. Hudi's part still TBD inside their repo. But anyway, so if you're a Delta Lake user or a Databricks user, this is great news. You can have that interop. But if you need to go the other direction, it doesn't provide that capability, nor does it foster a neutral environment for all these projects to come together and collaborate and have productive debate and discussions on these developments as well. So yeah, read this for more in depth, and it talks about the differences.
Okay, everyone, we are at time. Thank you so much for attending today and for giving questions and comments that have been fed into us and that we've used to liven up this discussion. Tons more to say, but we've used this hour well. And here's how to learn more. Please direct your friends, I won't say to burden your family, but your friends and colleagues with the recording so we can spread the learning around and have a great discussion going forward.
Yes, yes.
Thank you.
If you want to learn how you can build a Hudi Delta Iceberg Lakehouse in minutes, come check out our product at OneHouse. We got blogs, chat with us on Slack, find us on Twitter, LinkedIn, or info@onehouse.ai. Love to chat some more. So thanks, Floyd, for guiding us through. Thanks, everyone.
Cheers. Bye.